Hey guys, this video goes with non-traditional day 5, and we're going to be reviewing z-scores and the normal curve. First off, remember the formula for a z-score is right here. We're going to be using this throughout the lesson, and we especially want to remember it for example 6 and 7. So let's jump straight into some examples. It says, suppose your statistics teacher reports test grades as z-scores, and you got a score of negative 2.5 on an exam. Write a sentence explaining what that means. Well, this means that my score was 2.5 standard deviations below the test average. Okay? So that is what it means as a sentence. For example, if the test average was an 80 with a standard deviation of 4, you were 2.5 fours below the average. So you would do 80 minus 2.5, and the standard deviation was worth 4, so you were 2.5 fours below the average, so you scored a 70. Next, the mean score in the stats exam was 82 with a standard deviation of 3 points, and Charlie's z-score was a negative 2. How many points did he score? Well, the average was 82, and his z-score was 2, so he was 2 standard deviations below. Well, what was the standard deviation worth? It's worth 3. So he scored a 76. Next, the mean score on the stats exam was 72 with a standard deviation of 7 points, and Edie's z-score was a 2.5. How many points did she score? Well, she was 2.5 z-scores above, and a standard deviation is worth 7, so Edie scored an 89.5. All right, well, let's go back to this normal curve that we loved so much first semester. Remember, 50% of your data is going to fall on either side of your mean, so above and below. 68% is within 1 standard deviation of the mean, 95% is within 2 standard deviations, and 99.7% of the data is within 3 standard deviations. So it says a basketball player averages 34 points a game with a standard deviation of 4 points. Assuming that the data is normally distributed, what percentage of games does a player not score below 30? Well, we fill out our normal curve and we put our mean here, and then I add 4 in this direction and I add 4 in this direction. And I'm concerned with not below 30, so I'm going to go this way, not below 30. I add up these 1, 2, 3, 4, 5 numbers respectively, and I get 84%. Notice here that I just had 2.5 because I know that these two together are 2.5%. So 84% did not score below 30, which means that 16% did score below 30. Okay? Next example, it says the heights of American men aged 18 to 24 are approximately normally distributed with a mean of 68 inches and a standard deviation of 2.5 inches. About 32% of young men have heights outside the range what? Well, 32% outside, we know that there's 68% inside. So if there's 68% inside, 1 standard deviation of the mean, it means there's a remaining 32% out here. Since things are symmetrical, it makes sense that if 68's in the middle, that you can cut off the remaining 32% into 2 equal pieces, 16 and 16. So the two numbers that mark those spots are 65.5 and 70.5. Next, when answers are not directly on the curve, we have to go to our table or the calculator that I taught you guys this year. And if a student averages 74 points on a test, has a standard deviation of 4, assuming the data is normally distributed, what percentage of tests does the player not score above 77? Well, if you don't score above 77, you score below 77. And since our table represents values below, we can go straight to our table and boom, we've got the answer. First, I have to do the formula, which is whatever value they gave you minus the mean divided by their standard deviation, and that gives you 3 over 4, which is 0.75. And I locate 0.75 on my table, which you guys can see right here, and I get 77.34.
Correlate for
And
high expectations is now meeting at 2:30 in Miss Coach's room. Again, the correlate for high expectations, you all are meeting in Miss Coach's room with high expectations.
okay, they do announcements on our work days too. So there you guys go. My meeting's about to start. For our final, and so that was 77.34%. For our final example, it says that if a football team averages 17 points and has a standard deviation of 4 points, assuming the data is normally distributed, find the probability that the team scores above 10 points. So we are going to look to our table, but then we have to subtract it from 100 because the data value that our table gives us is what's below and not what's above. I take the value they gave me, 10, I subtract off my average and I divide it by my standard deviation, and I get negative 1.75. I go to my table, negative 1.75 gives me the value 0.0401. I subtract that from 100 and I get 95.99%. Once again, email me with questions, practice these practice problems on your own sheet of paper that you'll turn into me, and then you'll submit your exit slip through a Google form. Good luck, guys. Thanks.